We're often interested in establishing physically reasonable rate expressions that best fit experimental rate data. As we've seen, different mechanisms result in rate expressions with distinct relationships to partial pressures of reactants and products. So our first criterion for discerning between proposed reaction mechanisms is the goodness of fit between measured and predicted partial pressure dependent rates. Let's consider this for an example reaction A going to B. So let's say we have some experimentally measured rate data shown here in the open circles. So we can propose two different sequences of elementary steps from which we arrive at rate expressions that look like this. So here we can see that there's very different dependence on the partial pressure of A for the two models, with a partial pressure dependence for our first model that would look something like this, whereas we would have a much worse fit for our second model and a lot of deviation between the predicted and experimental data at high pressures. The second criterion for model discrimination is how reasonable the model parameters are from a physical perspective. So these are the activation and adsorption energies. So the following guidelines are useful for ensuring reasonable values. First, the enthalpy of adsorption should be negative. So adsorption is always exothermic. Secondly, molecules should lose entropy upon adsorption. Thirdly, a molecule can only lose as much entropy as it had in the gas phase. So we can write that the entropy change upon adsorption has to be less than the entropy of the gas phase molecule. The values themselves should also have reasonable both absolute and relative values to one another. This takes some judgment, but we'll see how, for example, adsorption energies of similar molecules are highly correlated, and further steps with significant bond rearrangements should have higher barriers than ones that are chemically facile. Finally, for all other things equal, we can take the wisdom of Occam's razor and say that the simplest reaction mechanism is the one that's preferred if we have no other method for distinguishing between the two. So we'll look at some examples of using experimental rate data to discriminate between proposed reaction mechanisms.